Okay, let's take a look at AP topic 8.13, arc length, measuring the length of an arc and the distance traveled. This is an example of a BC topic that's not a BC topic because it's difficult, but because everything can't simply be in calculus AB. It's actually a pretty easy idea. So the idea is, let's imagine that we have some kind of curve, and we want to measure the length along that curve from some starting point, we'll call that A, and an end point B. So we want to figure out, what is this distance that's traveled here along that curve? And that's something we can't do with algebra, but we can do it with calculus. And there's a formula that you need to memorize that we use to measure the arc length. And it's the integral from the lower bound to the upper bound from A to B. And then it's the square root of 1 plus the first derivative of that function that makes the curve squared. And I'll tell you right now that the most common mistake people make whenever they work these problems is working with that squared. And we'll take a look at that in a second. So we'll do one example. These really aren't that big of a deal. I do want to point out you can also find arc length along a curve if the function is defined by y instead of x. No big deal. So here we go. Let's find the length along the curve with bounds of 1 to 3. And our curve is going to be the function, let's do 2x squared plus 4x plus 7. Okay, so the first thing we need to do is take the derivative of the function. So we'll get 4x plus 4. And then we need to square that derivative. That's going to be useful for us. And so in this case, 4x plus 4 getting squared, we're going to have to FOIL that. 4x times 4x, 16x squared. 4x times 4 is 16x, and we'll have two of those, so 32x, and then another 16 at the end. So our integral is going to be, we're going to integrate from 1 to 3 of the square root of 1 plus, and then we're going to take all of this first derivative squared, and we're going to put it in to the square root, just like this. And then we can take a calculator and we can integrate that. And at the end of the day, that's it. It's really not that big of a deal. Now, I will show you a quick other example of maybe when someone might make a silly mistake. Let's just take the function 2x squared without the rest of what we just had. So the first derivative is 4x. So a common mistake someone might make, and this is a different problem now, is that someone will go to put this stuff in here, and they know that they need the first derivative squared. And so what a mistake people will often make is that they will take that and they'll just square it incorrectly and call it 16x, or they'll square it incorrectly and call it 4x squared. So just make sure that you're squaring both parts whenever you have a single term like that. So it would be the integral from 1 to 3 of the square root of 1 plus, and it would be 16x squared dx. There you go. That's the gist of it. Good luck.